Hi everyone, welcome back to ANR Academy. This is Nepaledi sir. Today we are going to discuss the history of logarithm. In general, we can define logarithm as that is inverse of exponential. Inverse of exponential is logarithm, that is correct. But what is the history behind logarithms? Let us discuss now. The word logarithm, that is the combination of two Greek words. One is logos and the second one arithms. Logos means logic or a relation, and arithms nothing but numbers. So a logic between the numbers is known as logarithms. Let us discuss what is the logic behind the numbers. Suppose that I am going to select sequence of numbers which are in geometric progression first. I am going to start with 1. With common ratio 2, I am going to write the remaining entries. That is next number 2, and then you will get 4. After that we get 8, and then 16. After that 32, next 64, 128, and finally we get 256. These are sequence of numbers which are in geometric progression, and the base of this, they are having common ratio 2. In the second column I am going to write sequence of numbers which are in arithmetic progression. We know that the sequence of numbers with common difference known as arithmetic progression. Here the difference I am going to select 1 unit. Let us start with 0. 0 is first element in arithmetic progression. Due to common difference 1, the next numbers I can write 1, 2, 3, 4, 5, 6, 7 and 8. Here 0 to 8, these are the numbers corresponding to geometric progression terms 1 to 256 with common ratio 2. This logarithmic tool is helpful to find nth root of a number, and also we know that suppose there are numbers which are large numerals. Addition and subtraction of those two large numbers is very easy to you, but multiplying and dividing those two large numbers we feel difficulty. To avoid this difficulty, we have this logarithmic tool. Let us observe. Here I am going to multiply 2 with 16. Here I am going to apply the operation multiplication. 16 into 2, that gives the result 32. The result you have here. Here 2 and 16 are small numerals, so we can easily multiply these two numbers. If suppose if you have large numerals, then it is difficult to multiplication. So for such type of models, see the logic. Corresponding arithmetic progression element I am going to select here and here. This is 4, right? Here the question is multiply 2 with 16. But what I am doing, here 2 comma 16 are sequence of terms in GP. Instead of 2 and 16, I am going to select the corresponding elements which are in AP. These are the numbers 1 and 4. Now I am not going to apply multiplication. Here I am going to add up these two numbers. Then what we get? 1 plus 4, that become 5, that you have here. Here sum of these two numbers is 5 and corresponding GP now in the reverse direction, that is the result of product of these two numbers. So that when you feel difficulty to multiply large numerals, you have to write the corresponding arithmetic progression terms in the right side. Adding up, you will get easily a term, corresponding term which is in GP, that gives the result. Not only multiplication, if you feel difficulty in division, also it is possible by this technique. Suppose that sequence of terms in GP and AP, the same I am going to write with common ratio 2, and here I am going to select common difference 1. Start with 1 with ratio 2, next element 2, and then 4, after that 8, next 16, and then 32, 64, 128, after that you will get 256. Start with 0 with the difference 1, sequence of terms now in AP in the second column. So 0, 1, 2, 3, 4, 5, 6, 7, 8 we get. I am going to divide 32 with 2. 32 I am going to divide with 2. What we get? 16 is your answer. Yes. Here the result is 16. Suppose if there are large numerals, if you feel difficulty to divide those numbers, in such cases you follow like this. Write the corresponding entry in the second column, which is in arithmetic progression. Next, here it is 5. Selecting corresponding elements which are in AP. After that, instead of division, here apply subtraction. 5 minus 1, that gives the result 4, and corresponding entry in GP, that is the result after dividing 32 with 2. So when the given numbers are large numerals, it is very clear that just without doing multiplication and division, you have to choose corresponding elements in a arithmetic progression, and there instead of multiplication you have to apply addition, instead of division you have to apply subtraction, and the result you have to mention on the table, and the corresponding entry in the first column is the result. Also, suppose if you need to find square root of 256, if you need to find root over 256, you know that the result is 16. Observe in the tabular form, here you have 256, 3-digit large numeral. Instead of this, select the term, corresponding term which is in AP. Next, here the question is square root of 256. Whenever in geometric progression we need square root of a number, in arithmetic progression you have to select division of corresponding number with 2. Remember, suppose if I divide this with 2, 8 by 2, that gives the result 4 here, and the corresponding entry, that is 16, is your answer. Given number 256 in GP, but we are going to select the corresponding AP in the second column, that is 8. To find square root of the given number, what we are doing, just we are dividing with 2. After division you will get 4. Corresponding GP is the result of square root of 256. So here in the first column you have sequence of numbers in GP, and the second column consists sequence of numbers in AP, and there is a connection in between those numbers, so that there is a logic behind the numbers, implies logical numbers. Logic behind the numbers is known as, numbers is nothing but algorithms, logic means logos. So combination of these two words, logarithm, that's all. So this is about the history of logarithm. Actual definition of logarithm is, that is inverse of exponential, that is 100% correct, but the history is just logarithmic is a tool that gives the relation between sequence of terms which are in AP and GP, remember. I hope you have understood everything. The students, those who are watching my videos, please subscribe the channel and please like, share and comment. Thank you so much.